Thank you so much for joining the Browsers and Platforms track. If you were here yesterday or even on Monday, you may have heard us talking about the challenges of getting IPFS and even protocols or features like it into places like browsers, into places like open source command line tooling, having it working on mobile. The initial architectures of IPFS are really designed around this monolithic service that runs on a desktop computer or in a server, when most of the billions of people using the internet use it in very different ways every single day. So we need to be able to have this protocol be in those places and operate in a way that users can expect, that developers can actually work with, and hopefully that actually brings you some of the characteristics of the protocol, things like content addressing, transport agnostic networking, and the ability for people to interact directly with each other. So I'm going to kick it off with a little bit of examples of the type of work that we've done, some of the things that the people we work with. We work with a bunch of different browsers on the team that I have, Browsers and Platforms team at Protocol Labs. We also work with open source libraries. We integrate into open source communities, and we bring things like IPFS or parts of that stack out into places like the space industry. We work with metaverse projects. Basically anywhere that HTTP is today and can be, we have as a target where we think that things like IPFS should be able to run. Oftentimes that looks a lot different, and these are some of the projects that you're gonna hear from today, are projects who are putting these capabilities into places where it might look different than, say, just running an IPFS node. This year, a couple of interesting things happened. We had to rewrite the IPFS companion extension, so running IPFS inside browsers, not even as a native protocol, but even inside a browser extension is pretty challenging. And Google has a new format for extensions called Manifest v3, which obliterates all of the API set and models that you had for extensions before, and most extension developers are having to rewrite their extensions from scratch. David on our team did that this year, only because Google really pushed their deadline on that. They're like, you're gonna have to do this, you're gonna have to rewrite everything, you have to ship it by this time. And then they kicked that deadline to next year. So we're ready whenever Google is to ship new versions of our extensions. We also shipped, along with MetaMask, they shipped a new architecture for MetaMask called Flask, which is the idea of extensibility inside MetaMask itself. And so we worked with them to ship an extension, or they call it a snap, inside MetaMask that adds Filecoin support to it. This is another inception kind of thing where you have an extension inside a browser. And it's going to be interesting to see when Flask actually goes to production, how this model plays out. And they're probably, already experiencing a bunch of the challenges that browser extensions as a platform generally have. But it was a really big accomplishment for them to be able to ship this Flask version. You can test this today if you look up MetaMask Flask in any of the browser extension stores. With Ayala, who you'll hear from Javi later today, we've been working for a long time on a number of different web platform compatibility fixes and other things like adding support for protocols like IPFS inside Register Protocol Handler. And this year started working on a much more ambitious project that he will tell you a bunch about making it easier to add non-HTTP protocols inside the Chromium codebase. So Chromium, the codebase that Chrome is built on, Brave is built on, Microsoft Edge is built on, Opera, and a whole bunch of other browsers, even some of the more independent browsers that you'll hear from today. So getting IPFS support of some kind inside there is really, really high leverage for the protocol itself and makes it available for products like browsers to be able to choose. Brave, you'll hear from Oni today about a bunch of the features that they've shipped. He's gonna give a wide overview of everything from how we added schemes in there, IPFS local node support, and the Filecoin support. Some of the things upcoming are things like automatic pinning of NFTs when you have them in your wallet inside Brave. So more and more features of people's experience online being integrated into the browser experience in different ways. We also work a lot on trying to figure out what the right pattern is on mobile for people to get some of the characteristics of IPFS in people's hands. You can't really realistically run an IPFS node on a mobile device because it opens up hundreds of sockets, which is not really possible over something like a SIM card connection, an actual mobile connection. And a lot of the use cases too, like is gonna bring your battery down anyways, which is a real challenge. So there's a number of challenges around getting it to actually bring, getting it working in mobile in a way that actually brings some of these features. And we're experimenting in ways like maybe we talk to a bunch of different gateways to be able to get a bunch of blocks as opposed to just one gateway. So even though you're not running libp2p, you are actually decentralizing how you're using the HTTP IPFS network. So having to get creative on mobile, you'll hear probably 3 or 4 different approaches of getting creative on mobile from projects that are going to be speaking today. We also work with open source libraries, so things like curl. What would IPFS support inside curl actually look like? Well, if you have a local IPFS node, then it might be kind of straightforward if curl knew about it and knew where to look. But if you don't have a local IPFS node, can you still pull from a gateway or from multiple gateways? These are some of the experiments that we're doing with open source projects like curl and FFmpeg to be able to have those tools pull video, audio, network assets in the way that developers do today, but maybe with some like environment variables and configuration, maybe a little bit of glue in there to talk to local nodes, taking a bunch of different routes to try to figure out how that might actually work. We don't know yet, but we're learning a ton as we work with these different communities. And the nature of this work is something that our team does a bunch. And we met earlier in Iceland with a bunch of people implementing IPFS or building on top of it to talk about these challenges. And this was, I think, in July. And it really set the stage for having these conversations here today with this community around really broadening that. Now that we've kind of, as a core IPFS community, have realized, all right, we need this to work in a different way. We need it to work where developers are, where end users are holding devices in their hands, or sometimes in a satellite roving around the planet. IPFS needs to function differently, and it needs to be more available and accessible. And so this was a really big turning point in how we thought about what IPFS is and how it works. And so you're gonna hear today a bunch of stories of different people doing this type of work. One of the big accomplishments that we had this year was the fact that this is now getting close to 50-50 green versus red. It's really, really long, painstaking work to be able to do things like add a paradigmatically different protocol with different security model, different privacy model, different capabilities to something like the web platform. This is probably a 10-year path to get this green. If not more. And we're bringing in some of these timelines pretty rapidly, like just between the difference between March and October that I animated here in GIF fashion is kind of amazing. And I think as IPFS gets more well-known and we hammer out some of these new patterns and pathways, maybe we can make it less than 10 years, 5 years. We'll see. Who knows what happens? But you'll hear about some of the real spikes in the activity and some of the accomplishments that we made in 2023 today from the speakers. We also announced last January a project with Lockheed Martin to put IPFS in space. And this is really going to, you're going to hear a lot more about this in 2023, but we're looking at user stories and use cases like I need to access data from a satellite that is only available 6 minutes a day to 38 ground stations and access the aggregate set of data available from the sensors that are emitting data in a way that I can reason about as an application developer. So things like this, IPFS and content addressing, where you don't have to worry about where the data is or who has it, and you can ask the network generally, hey, I got this CID based on this IPNS key. Anybody have this block inside this larger graph? IPFS aligns really well to these semi-offline, often disconnected or disjoint data sets scenarios. So there's a lot of interest in the space industry around using IPFS for more easily available and less complex application architectures. So you'll hear some more about that over probably the next couple of years. The team that I work on right now is a very small group of people, but as you can see, a very expansive focus, and we work across a lot of different areas, and we work a lot of organizations and projects and people outside our core team, as you saw at the beginning there, are kind of, you'll recognize a few of these people. They will be speaking here today. If you see any of them walking around, reach out and say hi, introduce yourself. We're also hiring for a bunch of different roles. If you're interested, come and talk to me about some of these ones at the bottom there. And our strategy really, in large, as a team, is to make it so that IPFS is available in places so that developers and users can choose it. The developer adoption oftentimes is around, hey, I'm gonna build a thing, and the people will be just so awesome, people will come to me and they will want it. But the way, if we want to address target markets like IoT or video as a category or games. You have to be in the places where those people are doing their work. And that is the strategy that we have as a team, is to make IPFS something that in these environments, it is available for them to choose. And that's a real different way of operating. It means you need to engage those communities, you need to work with those projects, you need to understand their, everything from their community process to their coding styles to the ebb and flow of decision making in open source communities or even inside private companies. So it's interesting and challenging and fun. One of the challenges that we have is that when you have a world where everybody has HTTP blinders on, and that's the only lens through which they've evaluated what the risks, trade-offs, privacy, security, or capabilities of a protocol are, IPFS seems kind of crazy. So we spent a bunch of time working with folks who are interested in IPFS, and then the more they learned about it, at first the crazier it seems, and after a while, once they kind of grok the value of content addressing and transport agnostic application architectures, they're like, I get where that value is, and I understand why the trade-offs that you're making are different compared to what you would do with HTTP, the trade-offs you would have to make, the relative risks and capabilities that you get in return for those. Thanks everybody who showed up to, well, one, to this event, and also to the IPFS Iceland Summit, PDP Paris, and a bunch of the other different events that we had this year, where people came together to really explore what it would look like for IPFS to be in places where it isn't today. Some of those folks are still in line, so I'm gonna change up the speaker order a little bit, and we're going to start with Lytle, who will tell you about the state of IPFS gateways.